Lesson for today, comparing theoretical probability with experimental probability. When you conduct an experiment, you start off with a prediction, then conduct the actual experiment. Sometimes your results will match your prediction, and sometimes they will not. So if you think about the coin flipping experiment that we did the other day, sometimes if you flip a coin 10 times, you'll get 5 heads and 5 tails. But sometimes when you flip a coin 10 times, you'll get 2 heads and 8 tails. So your theoretical probability and your experimental probability aren't always the same. A probability experiment is used to test the conditions of a certain event actually occurring. The same concept applies to probability experiments. When conducting a probability experiment, your predicted outcome is referred to as the theoretical probability, and your actual outcome is the experimental probability. So your theoretical probability is what you think is going to happen, and the experimental probability is what actually happened. Theoretical probability uses a formula to determine the outcome of an event, whereas experimental probability uses the results of an actual experiment to determine the outcome of an event. Theoretical probability is based on the reasoning that each outcome has an equal chance of occurring. The probability formula is: the probability of your favorable outcome is equal to the number of favorable outcomes over the number of possible outcomes. This formula is used to calculate theoretical probability. The favorable outcomes are determined using logical reasoning and are placed over the total possible outcomes. For example, tossing a coin. What is the theoretical probability of tossing heads on a coin? Substitute the known values into the probability formula and simplify. The favorable outcome is heads, and there is only one head on a coin. The total possible outcomes are tossing heads or tails, which means there are 2 possible outcomes. The probability of heads equals favorable outcomes over the total possible outcomes, or 1 over 2, which is equal to 0.5, also equal to 50%. The same formula is used to express experimental probability. The favorable outcomes are the outcomes that have happened, and they are placed over the total number of times the experiment was conducted. Here's your activity. Tossing a coin. Perform a simulation by tossing a coin 20 times and record the results of each toss. You may get the following results: 14 heads and 16 tails. The experimental probability of tossing heads in this simulation is as follows. Probability of heads equals number of favorable outcomes over total number of possible outcomes, or 14 out of 20 equals 0.7, or 70%. So I want you to pause the video now and actually do this activity. Toss a coin 20 times and record the results of each toss. So you should have your coin. You should be flipping it. Yellow. Write down yellow. Flip it. Flip it. Yellow. Write down yellow. What were your results? Pro tip: how to flip a coin. Hold it on your finger so it's half on your finger, half not, and flick with your thumb. Don't try to throw it, flick it. Okay, now that you've completed the activity of tossing a coin, I'd love to hear what your results were. Comparing probabilities. How do the results from calculating the theoretical probability compare to conducting a probability experiment? Experimental probabilities are often different than theoretical probabilities. This is because theoretical probability is based on results that are calculated as if the variables in the experiment were perfect and there were no outside influences. When you're calculating theoretical probability, you're making a prediction, and not all the results of an experiment will match the prediction. And that's your lesson for today. Enjoy.